Washington State University. Go Cougs!
Now, a lot of data that we actually have in the health sciences is correlational data, because we can't always assign people to conditions, right? We can't say you have high blood pressure, you have low blood pressure, you have diabetes, you don't have diabetes. These are risk factors or things that people have or they don't have. And so oftentimes the best that we can do is say, is diabetes linked to Alzheimer's disease? So is there some sort of relationship between that? But what we can't do with correlational type designs is infer causation like we can from the experiment. So in the experiment, if I manipulated planning and I saw better performance, I could say planning ahead caused better performance. But if I can't manipulate who has diabetes and who doesn't, I can't say that not having diabetes leads you to not have Alzheimer's disease. I can say there looks to be a relationship if I can show that the two are related. So one of the ways that we've used correlational data with our sensors in the smart home is we have looked at how well people have completed everyday activities in the smart home. So we have said things like, now I want you to go wash the countertops and sweep the floor, or we'd like you to water these plants, or we would like you to fill this medication holder. And we've coded how well they've done that. We looked for different errors that they did. We looked for how efficient they were at doing that. And we came up with an observation score of how well they were doing that. And we had to show that our direct observation score was actually related to some other measures of everyday functioning so that it looked like it was a good, reliable measure, and that we had good reliability between different coders. And then we decided that that would be our measure of ground truth for how well people were doing. And we looked to see whether we could use the sensor data that we were getting as people were doing the activities to tell us about how well they were doing the activities. So basically, could we use sensors in a home to actually tell us about people's everyday functioning? And we were able to find a correlation of about 0.60 or so, which suggested that we were seeing some relationship between the sensor data and the direct observation score. If there's no relationship, when you look at the data, you're just going to see kind of like dots that aren't going to be in any pattern. You could see negative relationships, and this is kind of a small to moderate relationship. Or you could see positive relationships, and this is a strong relationship here of about 0.86. So when you're looking at correlational data, it can vary between -1, so as one thing's going up, the other thing's going down. So for example, as your engagement in health-related behaviors goes up, your weight goes down. So you would actually see a negative correlation versus two things that would go up together. So you know, your good high-density lipoproteins go up as you exercise more. That would be a positive relationship. So you can get positive and negative correlations. Okay, so does that make sense to everyone? So experiments versus correlations. Another type of method that we can use is naturalistic observation. So here, we're just going to observe people in their everyday setting. We're not going to attempt to intervene in any way. We're not going to manipulate anything. We're not going to control anything. We're just going to watch people as they interact. So I think one of the first experiments, I think when I was teaching 198, one of the student groups wanted to look at who would press the button for the door, the handicap button, to go inside. And so there they just sat there, they observed, they didn't interfere in any way, they just took down information about what was happening. And that would be more of a naturalistic observation. Now here, you don't have any experimental control. So can you think about maybe some things that could have an effect on whether a person pressed that handicap button or not. Declan. Okay, so if there's people standing or blocking the way, they might not press it. When might someone be more likely to press it? If their hands are full, yeah. You know, how many people have done that? So you don't really have control over things that are happening in the environment. If someone like observes you there, right, just having an observer in the environment, that could also bias what's happening, so we call that reactivity. The one thing about naturalistic studies and why we have worked so hard to be able to do more studies in a naturalistic environment is that they have higher ecological validity. That means that they're more likely to be able to tell us about how people are functioning in their real world. When I do a task in the laboratory, so I bring people in and I want to know how they're managing their medication. This is one we're working on right now. How are they managing their medication in the real world environment? So I have this test called the MMAA, the Medication Management, I don't know, something. And so basically what they have to do is, you know, I give them these fake medications and then I say, here, you know, read the labels, and now I want you to pretend to walk me through the day and give me the medications as you would take them. So what I want to conclude is that how well they do on that test I give them in the laboratory actually reflects how well they're doing with their medications in their everyday environment. But it may not, and oftentimes it does not. And so trying to create ways of collecting data that have higher ecological validity is important. And that's actually one of the things that got me so interested in sensor-based data to begin with. Because if we can find ways to get information about how people are functioning in their everyday environment, then we can have better ecological validity with our data, and we can also use that data then to create better measures in the clinic that reflect how people are doing in the everyday environment. So this is just really up here to remind me of kind of one way, we have some manipulation here, but we're trying to look at naturalistic things besides using sensors in the environment. And basically what we did was we gave people $20 and we asked them to go deposit the $20 in their bank, get the money, and then they needed to go shopping for some items that they would then use when we came to their home next time to make a meal. And what we did was we asked them to wear a little camera when they went out shopping. We couldn't do it at the bank because we didn't want to get routing numbers and other personal information. And there were also some rules like once you got up to the checkout counter, you would to turn it off because there would be an interaction with someone else. So it wasn't perfect in the sense that they would completely forget they were being monitored, right? But what we were trying to do is capture something that was very naturalistic in the everyday environment, how they were shopping. Another type of way to get data is psychobiological studies. And a couple of examples there are if you're interested in looking at changes in the brain and how they're related to cognition, you could look at, for example, how many plaques and tangles are in a person's brain and how that relates to their cognitive functioning prior to death. So you would get that data after death. You could work with brain damaged individuals, and this is something neuropsychology, that's the whole, what I do, that's the whole study. We work with people with brain injuries and we relate that to cognition. You could also use other tasks, like now we have things like PET and fMRI, where you can put people in these scanners and you can ask them to do different tasks and you can actually see how their brain is functioning, like what areas of their brain are involved as they are doing these different tasks. So these types of studies are really, really interesting in terms of helping us learn about the connection between what's happening in the brain and a person's behavior or their cognition. But one of the things is, first of all, they're expensive. Like if you want to do an fMRI or a PET study, you know, that can be $500 or more just to put someone in the scanner for one experiment. Usually they have small samples, and sometimes there may be very limited accessibility to the participants. I mean, when we try to get individuals with mild cognitive impairment and Alzheimer's or Parkinson's disease into our study, it takes a lot of recruitment, a lot of effort, a lot of time trying to go out and get those people, find them, get them to participate in the studies. So one of the things that's happened recently is that there are a lot of big network studies that are going on. So there are a lot of initiatives within NIH to create these larger data sets. So instead of having all these small data sets with different information in it, we're finding ways to bring these common elements all together. So ADNI is an Alzheimer's disease neuroimaging initiative. So people can go in and use data that's collected from all these different centers that's put in this central repository. There's the TBI Model Systems Network. So people with traumatic brain injury, they've got a lot of data coming into this one repository that people can look at. Most recently, there was a CART initiative funded, and this is a smart home initiative where they're going to try to develop a smart home platform that will then go out and researchers at different locations will be using that same platform. Right now, most of the different groups that are doing smart home research have different platforms that they're using. So this is an example of one of our studies where we basically have people that we're following longitudinally in smart homes. We're testing them bi-yearly. We're doing monthly health calls. And what we're interested in looking at is that natural history of change from mild cognitive impairment to dementia. But when we're doing these psychobiological studies, you can see that one, this sort of study can take a long time, and two, we have to wait for these people to transition, right? We have to find the right people and watch them transition from mild cognitive impairment into dementia, or from healthy aging into mild cognitive impairment.